For the last video in this section, we're going to talk about trinomials that factor as perfect squares. So this is kind of an optional method of factoring that only works for a few trinomials, but it's kind of a shortcut for certain types of trinomials, the trinomials that we call perfect square trinomials, because of how they factor. So it looks like this: a squared plus 2ab plus b squared equals a plus b squared. And then we have a similar one with subtracting. So subtracting in the middle term, right, and subtracting here. And all this is if you took a plus b squared and you multiplied it out, you get a squared plus twice the product of a and b plus b squared. Why twice the product of a and b? Well, because if you wrote out a plus b times a plus b, you get you get a b times a and an a times b, which is 2ab, the middle term, right? And the same thing here. So this thing on the right is called a perfect square, but we often call the expressions on the left perfect squares as well, because they can be factored as perfect squares. So this is an important note here. These can be tricky to spot. Like you're looking at a trinomial, and most people don't actually spot that it's a perfect square. That doesn't matter that much, because all you have to do, if you don't spot it, is you just do this the way you do any other trinomial. So, that's why this is kind of the weakest one factoring method we have, because it's the least useful. Okay. But you should know these formulas because they're used in the other direction, actually to multiply out a binomial squared very quickly. Okay, so this is called the binomial formula degree 2. What is called the binomial formula degree 2? This formula. And this formula is really the same formula, it's just that your b is negative. So we'll do an example. 4x squared plus 12x plus 9. Now, the first thing I should look for is, do all three terms have a common factor? Well, they don't, because 2, which is a factor of 4, actually 4 is 2 times 2, but there's no 2 in the 9, no factor of 2 there. See, so I can't factor out a common factor, bummer. So I'm thinking maybe this is a perfect square, since that's what section I'm in. Well, you've got this guy. You have to think, okay, I need to find out what a and b are, right? Of course, these are all plus, so we'll use the plus one. So what is a? It's whatever's being squared. The 2 is being squared, and there's an x being squared. So 2x is a. And you could even write a equals 2x if that helps you. B is 3. It's the thing that's being squared here. The b here, this capital B, is 3. So my answer is going to be 2x plus 3 squared. There's no conjugates here. The conjugates are for difference of two squares. This is for a perfect square. It's a square of a difference, or a square of a sum. Now, I would always check this. So if you squared this, you would get the first term squared, which is 4x squared, right? The last term squared, which would be 9. And then you'll get a middle term, and the middle term is always going to be twice the product of these two. So the product of these two is 6x. Twice that is 12x. See? So that's really the important thing to remember, is if you multiply this out, you should know this shortcut to just write it out. It's much easier than trying to write 2x plus 3 times 2x plus 3 and then doing a bunch of arithmetic and missing a step. Okay? So that's really where this formula is used most often. It's not for factoring, but just multiplying out. If you're using it for multiplying out, that's called the binomial formula degree 2. And we'll do the binomial formula in the very last section of the book, but we'll do it for higher powers than 2 as well as 2. Okay, so that's it for that section.